Okay, so we are still in the serverless section, and I want to uh, finish off these slides here today in terms of a lab. I've actually made some changes to the lab that you were working on this week. So if we go into that, then there's a section, where is it? Did I put, oh yeah, there it is there. So you just need to go straight into that section on DynamoDB queries and local secondary indices. So it's just one section, but there is an exercise down at the end of it, which might take you, or might not, a little bit of time to walk through. So that's the lab work for what I'm going to say is next week, really. Now, before I dive into the slides, I just want to wrap up the TypeScript lab side of things. And by that, I mean, I'm just going to fly through the parts that I looked at in year submissions in terms of formulating a mark. So this would be fairly straightforward now. So I went into the functions and I looked at the all older. Let's see, sorry, no, wrong one. This one. Oh yeah, sorry, a bit slow. This one here. Uh, just an observation that I made. A lot of people uh, are using kind of for loops in general, not specific to TypeScript now, but in general, you should try and minimize the use of for loops in favor of using, in the case of TypeScript and JavaScript, in favor of using higher order functions like map and filter, reduce, and there are many others that we didn't look at, other that we didn't use. Um, Understanding these higher order functions is straightforward enough. The trick is, or the skill is, to identify when you have opportunities to use them. And so whenever you, just in general, this is a general comment, whenever you find yourself writing a for loop of any nature in any language, take a step back and ask yourself, can I actually express this using whatever the equivalent of higher order functions is in the language that you're currently working on. So in this case, in the case of the all older, we didn't have to use a for loop really. It was really a map operation that we were performing. Um, we were mapping over the friends in this, and okay, I used the older function, which we had defined within the lab itself. But if you didn't want to use that, that's okay. But I used it. The key thing though was to have identified that you could actually use map in your solution. Now, I didn't really take marks off people, if they had a for loop, but it's just something to be aware of, as they say, going forward, which I hate that expression, but anyway. The add collaborator was the next one that I looked at. And then when I looked at my sample solution here, it was scarily similar to some people's submission, which kind of leads me to wonder, did I leave my solutions up on GitHub, or it doesn't really matter. I'm not going to get into the the weeds of it, but anyway, the add collaborator one was pretty straightforward, really. There were no real surprises there. Stop me if you need to at any stage. Now, the next thing I looked at was the find friends method. And again, that was a nice opportunity to use both filter and map. I've actually kind of made it, I could have chained the map and friend invocations in one line of code here. I'm done it in two lines of code. Or have I? Yeah, I have. Yeah, I've called filter first, and then I've called map. But I could have chained them together, which would have been better. We always try to write as few lines of code as possible. I'm not spending a whole lot of time on these now, but because I think they're fairly straightforward. And the last thing I looked at in this file was the add interest, and the key thing there was that you first of all had to check whether the user already had an interest array, because interest was an optional field in the friends structure, if you remember. So you had to check first, was it there? If not, then just create an empty array and add the new interest to the array. And that was a nice example because it was an optional field. Like you couldn't just go, let's see, you couldn't just go like, if I take out that line, you're going to get an error straight away. And the error, if I open it up, the error is essentially telling you, look, it's possible that f.interest is undefined, and you can't do a push operation on the undefined value. Of course, undefined in this context means that there is no property called interest in the particular friend object that we're trying to push a string onto. Yeah. But TypeScript warns you about that. Whereas, and I know I've said this a number of times, if we were writing this in JavaScript, then there'd be no problem until you run the code. And eventually, when this method gets called and we pass in a friend object that doesn't have an interest array, then it crashes, right? And we don't discover that until that incident actually happens. Then next thing I did was I went into the type aliases file and I just looked at the get body. I did um, I did hint that you should use the reduce higher order function, which everybody did as far as I know. Again, the solution was scarily the submissions, many of the submissions were scarily similar to what I'm showing you here, but that's okay. I'm going to overlook that for now anyway. Other than that, there were no real uh, catches in here. Again, the nice thing about TypeScript, even though what I'm passing in here is, let's see, list is an array of, is a body list. And if we looked at body list, can we do that? Sorry, no, body list. Body list has an array of buddies within it, but a buddy could be a friend or a colleague. Yeah. So going back to going back to this guy, that means that list.members is an array of objects where an object could be a friend or a colleague. But when we do this condition test here, and if I now do a command K command I on this, you see, it is actually worked out that buddy must be of type friend. It's not saying it's of type friend or colleague. And the compiler, which is kind of working behind the scenes as I'm typing my code, has determined that, which is kind of nice. Moving on. The last thing I looked at was in this While here, I looked at the intersection method or function, sorry. And the key thing there was that you had to define a new type, which in my case, I just called it this. And I gave you the properties of that type. And so I have defined this type, and I said you should utilize utility types as much as possible in your definition of this. Now, in my case, I've defined it in here, and I just use the pick utility method, uh, as in here. So I'm picking some properties from friend, and I'm also picking some properties from collaborator to form this new type that I'm defining. What some people did was they just defined this thing as an interface, and they kind of manually defined the structure of that interface. But that's not utilizing the utility types. So a lot of people lost out on that. Anyway, that's that. I'll just pause for a second in case there are any questions on the specifics of what I've just talked my way through there, or more generally. No. Okay. Back to serverless. So we've talked a little bit about DynamoDB. We'll be writing a lot of, sorry, we've talked a lot about Lambda service. And we will be writing a lot of Lambdas right throughout this module, as it turns out. But at the end of the day, it's just a function which receives an event. It typically opens up that event object to find some parts of it, and it typically interacts with other services in order to perform some piece of logic. DynamoDB is another serverless service, but it's in the kind of state management side of things, and specifically databases, serverless database. So it's we categorize it as or it's often referred to as a NoSQL type database, which it is, but there is a lot more to DynamoDB than the other NoSQL databases that you might be familiar with, like MongoDB, which I think you studied in third year or somewhere along the line anyway. Cassandra, and there are many, many others. But as far as we're concerned, DynamoDB is in this NoSQL space. It's fully managed, which I think I've said to you before, fully managed is really a byword for serverless. You don't have to manage any of the kind of do the maintenance side of the underlying database server or the provisioning of it. You're spared all of that. By highly available, specifically to DynamoDB, it actually makes replicas of your database across 3 AZ zones. It does that for free. And so if any availability zone goes down, then we know what the purpose of AZ zones are. If any availability zone goes down, then you still have access to your database via one of the replicas. And again, you don't have to worry about declaring one of the replicas as being the master and the other as being slaves, and making sure that they're synchronized with one another. DynamoDB takes care of all of that for you for free. Well, free-ish. Schemaless means that records in a table can have different structures. There's no sense that when you declare a DynamoDB table, that you have to declare what the structure of the entries in that table should be. That's what we mean by schemaless. So it's perfectly valid from DynamoDB's perspective to have lots of records with different sets of attributes, different kind of structures to them. In fact, you're kind of encouraged to take that approach. Next, I'm saying it's integrated with IAM. Yeah, so IAM plays a role in terms of the security and access and authentication and authorization access to DynamoDB. And we'll probably see that a little bit later on as well. Enables event-driven programming. We'll actually see that at the very end of this module. What I'm getting at there is you can set up an architecture such that when some changes happen to a particular table in your database, like a new record is added or deleted or updated, that event can trigger the execution of a Lambda or trigger some other service to carry out some action. Yeah. As I said, we'll come back to that way down the line. Basics DynamoDB is made up. Okay, so the kind of the language of DynamoDB is similar to that of other databases, but then it has slightly other terms as well. So the notion of tables makes sense in DynamoDB. We know what a table is from databases in general. So that still stands up. Each table I'm saying here has a primary key. We know what primary keys are and their role. So that's the same. A table I'm saying here, a table's entries are termed items. I don't know why they chose that, but they did anyway, the DynamoDB people. So we don't, I mean, if we were to speak properly about DynamoDB, we don't talk about records in a table, we talk about items in a table. I suppose the idea is that records gives this sense of a schema being applied to a table, and everything in the table has the same structure. But as I've already said, that's not the case. So maybe that's the rationale behind it. So items are the entries in a table. I'm saying each item has attributes, but these attributes can be added and removed at any time from a particular item, and DynamoDB isn't going to complain. So that's very flexible. There is an upper limit on the size of an item, it seems. And DynamoDB also has its own data types. So it has scalars, which are the usual things you'd expect them to be. But then it has the document types. So what we're saying here is that a particular attribute of an item in a table could be a document, where a document is a list of things or a map structure. Yeah. Also, it has set types. And again, what we mean is that a particular attribute of an item in a table could be a set of strings or a set of numbers or a set of binary values. We won't worry too much about that. We'll keep it fairly simple, where I think all of our tables will have attributes that are scalars. This module is not really about database design or anything like that, although that aspect of DynamoDB is actually quite interesting when you start digging into it. But we just don't have time for that. We keep it fairly simple. Now, the primary key part of DynamoDB has some nuances to it that it's good to know, I suppose, let's say, rather than it being essential. Again, essential because it's not essential in our case because, again, this module is not all about databases, but we do need to know about these things anyway. So the primary key, there are two possibilities that your primary key may be. Option one is it's what's called a simple primary key. A simple primary key would be where the primary key is one particular attribute. It has one value. Yeah. So that's kind of what you would understand as being the primary key from other studies that you've done. When that is the case, the primary key is the same as the partition key. Now, partition key has a specific role in DynamoDB, which we'll see in one or two slides. Okay, but for now anyway, the primary key might be a single value, and in that case, we're saying that the primary key it also represents the role of the partition key for that table. I haven't told you yet, though, what the role of the partition key is. But the primary key, when it is of this simple type, the primary key must be unique, obviously. And also we would say that the partition key must be a unique value within the table. The partition key, its value range should be very diverse, and there's a reason for that. Again, we'll see why in a few minutes. And simple example, right? So I've got a table of users. So the user ID would be a good choice for the primary key stroke partition key for this kind of table. Nothing too exciting there, but we do need to come back to this notion of partition key. Alternatively, a table might have a composite primary key, where in this case, the primary key is comprised of two attributes. One of the attributes, again, has to play the role of the partition key, and the second one is what's often referred to as the sort key or range key. The combination has to be unique, as before, because after all, this combination is representing the primary key for the items in the table. So again, that combination has to be unique. And so what happens here is that when you've got a table with a composite primary key, what it means is that you will have a number of items in that table that will have the same partition key, but a different sort key. Okay, so there'll be a collection of items that will have the same partition key, but those items will be distinguished by the fact that they have a different sort key. But still, the sort key, partition key, comprises what we call the primary key. So we do have this notion of item collections within a table whose primary key is of this nature. And that item collection is grouped by the partition key, because that's what links them together, and they're ordered by the sort key. So if you queried a table for all of the items with a particular partition key value, you would get back the item collection, and you would be guaranteed that they would be ordered by the sort key, just as a convenience. DynamoDB does that for you. An example might be, let's supposing we're implementing some sort of game where you have lots of users, and there are a number of games that users can play, and we want a table that records which users have played which games and maybe what score have they got and when did they get that score, etc., etc. Okay, but in terms of the primary key for that table, it might be a combination of their user ID and, let's say, the game ID, because the user will have played multiple games, so there will be multiple records in this table for that particular user. So there'll be multiple records with the same partition key, and the game ID then will make each item unique when you combine it with the user ID. So again, that's a fairly straightforward example of a composite primary key. But I am choosing user ID as being the partition key part because there are going to be many more users than there are games. It wouldn't make sense to choose game ID as the partition key and user ID as the sort key, because we did say I think in the previous slide that the partition key, we said that the partition key has to be very wide, has to have a diverse range of values. It's right up here, actually. Look, partition key value range must be very diverse, must be a large range of possible values. We've seen this in this week's lab. So from a CDK point of view, how do I declare the provisioning, my requirement to provision a DynamoDB table? And we do it at the table level. We don't do it at the kind of database level from a provisioning point of view. We provision tables, okay? And so this is an example of the actual CDK code. And here we go. I wouldn't worry about the billing mode. I think this is just the default anyway, so I could have left it out. Here's my partition my primary key attribute. And in this case, it looks like it's a simple primary key. This corresponds to the name of the particular attribute within the table, what its type is. The reason I'm actually adding this attribute here, the removal policy, is when I CDK destroy a stack, then in this case here anyway, I want the actual table to be deleted as well. Now, clearly that wouldn't be a clever idea if this was a production application. You'd probably want the data to hang around because may want to use it in another application. But when you're only in development mode, setting the removal policy to this is, I think, is worthwhile because we just want to clean up after ourselves. And this is just the name of the table within the DynamoDB service itself. And you've looked around this. This is just showing you a screenshot from the management console, and you've played around with that in the lab. So we can move on from that. So back to this partition key and what its purpose is. Now, it turns out that DynamoDB was really designed for large tables, like large as in, almost hundreds of gigabytes, and certainly multiples of 10 gigabytes. So it stores those kind of tables across multiple partitions. A partition is simply a node, a computer within a fleet of nodes. And the reason it does that is it's nothing to do with kind of availability. It's got to do with consistency of performance. As in when you do read operations, you get a reasonably consistent response time from read operations. But in terms of the scaling anyway, I'm saying here that DynamoDB performs horizontal scaling out of the box, really. And I'm saying that the data is distributed across a fleet of computers or nodes, where a single node is often referred to as a partition. And so if we look at the diagram, so the way it works is, so if we want to write an item to a table, let's say it's our user games table that we're talking about. And so, okay, put item is the actual operation in DynamoDB to write a new item. And I'm giving it the primary key, which is a composite primary key in this case of user ID and game ID. There'd be other attributes as well. We don't need to show that here. We pass that to the DynamoDB service. Now, the particular part of the service is called the router. That's not really that important. This is effectively representing DynamoDB. And what DynamoDB does is it takes the partition key part of the primary key. It puts it through a hashing algorithm, and the hashing algorithm tells it which partition should it write that item to. Yeah. And we'll just say, let's supposing there is so much data in this particular database now that it has grown to 4 partitions. Initially, the table would be just one partition, but as we add more and more data, it starts splitting it up into multiple partitions. And really, once it gets close to 10 gigabytes, because I'm saying there in the first bullet point that the maximum size of a partition is 10 gigabytes. And obviously, there are indices in here as well. So let's assume we're at the state where the size of the table justifies 4 partitions. Okay, so for a write operation, DynamoDB uses the partition key value to determine which partition it should write the item to. And so that's why the partition key, whatever you choose to be the partition key for your particular table, that's why it should have a very diverse range of values. So you can get a good distribution of the items across these 4 partitions. Similarly, when you do a read operation in DynamoDB is a get item operation. And when we want to do a read of a particular item, we have to specify the full primary key. So in the case of our user games table, we have to specify both the user ID, which is our partition key, and the game ID, which is our sort key. But again, what the DynamoDB service does is it uses the partition key part of the primary key, puts it through this hashing algorithm. That tells it which of the partitions, and these are really just nodes in a network, which partition should it send the request to. So really DynamoDB is actually running on each of these partitions, and it will receive a request to get a particular item from a particular table with a partition with a primary key value, where the primary key in this case is a combination of partition key and sort key. And so, as I said, the way it designed DynamoDB in this way was for consistent performance, so that when we have a high volume of read operations hitting DynamoDB, all of those reads are not targeting one node. They're actually spread across a range of nodes. Yep. So that's that's my explanation behind the partition key part of this DynamoDB setup. DynamoDB, like every other service, has an API, a web API interface. That's how you communicate with it. And that web API has an SDK partnering it. So we use the SDK in our client's code. Our client code in our case will invariably be Lambdas. And just from in terms of the SDK that we use when we're writing our Lambdas in TypeScript stroke JavaScript, because it's really JavaScript, the SDK has 3 classes that are relevant when you're trying to communicate with the API. Okay, and I'm just specifying them here. So there's this DynamoDB client class, a DynamoDB streams class, and a DynamoDB document client class. Now, we don't care about this one here, right? We don't care about that. It's the other 2 that we use. And really, it's this third one that we use. So whenever we, in our Lambdas, whenever we want to perform some operation against a DynamoDB table, we're using this DynamoDB document client part of the SDK to program our requests. And behind the scenes, though, that is actually using the DynamoDB client. Okay, it's using that internally. This one here is kind of, we refer to it as the native client part of the SDK. This one over here is a nice kind of convenient wrapper of the native one to make our programming a little bit easier. And if you looked inside the package.json from the lab that you've completed this week, you'd see that I've included a number of dependencies, all related to DynamoDB. So it's kind of broken it up into a number of packages rather than putting it all into one package. Okay. So the DynamoDB API itself. So if we just drop down one level, I suppose. So we're not talking about the SDK now, but just the API itself. And we're trying to perform operations against that API. And it turns out that there are 3 types of operations. There are single item operations. So that's when you want to write one record, one item, Freudian slip. You want to write an item, you want to read one item, delete it or update it. So it's CRUD on a single item. And obviously for these single item operations, you have to specify the primary key, whether that be a simple primary key or a composite primary key. That's straightforward. That single item operations apply to tables that have a simple primary key or a composite primary key. The second type of operation are called query operations. Now, something I could have mentioned at the very beginning, right, is, so we're all familiar with SQL, right? DynamoDB does not have anything equivalent to SQL. And with SQL, as you know, you can write fairly complex queries, and you can query on the basis of attributes that are not the primary key of that relational database, right? SQL is obviously only for relational databases. But querying in DynamoDB is far more restricted than that, and it's quite difficult to get used to initially, and it does impact on your table designs, okay, which we're not going to go into, but it has a fairly significant impact on it because the querying options that are available to you are very limited. But anyway, I'm saying here that query are when you want to read a range of items, and queries only relate to tables that have composite primary keys. There's no sense of being able to query a table that has a simple primary key. Like if we go back to our users table, where the user ID was the primary key, right? You can't sort of query that table, for example, saying, give me all of the users. Let's supposing one of the properties of a user was their age, right? You can't write a query in DynamoDB of the form of give me all users whose age is less than 30. Instead, what you've got to do is you've got to read the entire table into your Lambda, let's say, and then go through that data programmatically to pick out the particular users that you want. Right? As that's just one example, right? So back to querying operations, they only relate to tables that have composite primary keys. I'm saying here, or it's not so much it's suitable, but you can only carry it out on tables with composite primary keys. Request must include, okay. Well, when you are querying, you must specify the primary, sorry, you must specify the partition key. So the kind of queries you can only make are, remember I talked about item collections. So I've got this table with a composite primary key, and the only kind of queries you can push against or perform against tables like that are give me all of the items that have a particular primary key value and the sort key has some other characteristic. Okay, you can't extend the query beyond the primary key part of an item. Can't go into the non-primary key attributes. We'll see an example in a while anyway. Second bullet point here, query results are always from, the query results are always from, they're always from the same partition because of the nature or item collection. Going back to here, here. Actually, yeah, so we're talking about the user games. So let's supposing this is the user games table over here. And a particular user has played, let's say, 5 games. We can be guaranteed that all of the items relating to that particular user are going to be on the same partition. Because of the way this hashing algorithm works, we can be guaranteed of that. And so when you're running a query in DynamoDB, the query results will always come from one partition within that table. You can't have queries that could possibly scan across a number of partitions just because of the way querying is restricted in DynamoDB. Okay, so that's queries. The third type of operation is a scan, which is effectively read all of the items from a table. And you can do that for either simple or composite primary key tables. Clearly, a scan operation is not a very efficient operation. Clearly, you don't want to be reading all the data from across 4 partitions, shoving that across the network and processing it within a Lambda. But sometimes that's the only option that you have. Okay, and so I should have said as well, or I could have said as well, in terms of database design, which I did say we don't want to really get into. You do need to, invariably, you do need to denormalize your data when you want to come up with the tables that make up a particular database in DynamoDB. Right, sample code. What am I showing you here? I am showing you, oh yeah, so this is just in terms of the SDK. I think that's what I want to show here. Yeah, it's just in terms of the SDK. Maybe I should have put this slide actually back a little bit further, but in terms of the SDK, and you've seen this anyway in this week's lab, you can see what I need to do is, first of all, I need to create an instance of a DynamoDB client. This is an example now of initialization code. Remember when we talked about Lambdas on day 1, I said a Lambda file is made up of 2 parts, the initialization code and the actual handler itself. Well, an example of initialization code is this line of code here, where I'm creating a connection essentially to the DynamoDB service, and it is regional based. Okay. And once I have that, then here's just an example of how I program a read request. In this case, sorry, is that what I'm doing? No, I'm doing something else here actually. What I'm doing here is, and I've left out a lot of code because the detail we don't really need to know about. What I'm doing here is configuring the marshalling and unmarshalling that I want to have associated with the client that I've created up here. And I've explained down here what I mean by marshalling and unmarshalling. You see, the problem is that DynamoDB has its own data types, and I talked about those a few slides back. But in our client code, which in our case would be our Lambda code, and specifically TypeScript stroke JavaScript, we like to deal with JavaScript objects, which is different to the types that are native to DynamoDB. So we need to kind of transform from one data type world to another data type world, and this is what we refer to as marshalling and unmarshalling. Unfortunately, the SDK will do that for us, provided we configure it in our DynamoDB client. And that's really what I'm kind of doing here. Again, it's kind of boilerplate, really. Eventually here, then I'm just showing you an example of how we program an actual request. And in this case, it looks like it's a read request. And we perform these using the DynamoDB document client. This here is actually a reference to a DynamoDB document client, which I have created elsewhere in this overall code. I'm not showing it to you here though. This DynamoDB document client, internally, it uses the native client, which is this one up here. But the DynamoDB document client, it really only has one method called send. And the parameters of this send method is what's referred to as a command object. This is the way the DynamoDB SDK is kind of designed. You want to send a command object, and the particular type of command object depends on what the nature of the request is. In this case, we just want to do a read of a single item from whatever table this represents here. Okay, and we'll see other examples of query commands, and I think the only 2 examples that I'll show you in these slides, but in the labs, I think you do a put command as well, which is a write. At some stage down the line, we'll do that. The get command then, We just create an instance of it. We've got to configure it as well with parameters. And in this case, you've got to tell it what table should the query be made against, and what is the value of the primary key. It just says key here, but that really means the primary key. And this, it looks like this table, its primary key is a simple primary key. Yeah. So again, though you've seen the full part of this code, these are only excerpts from this week's lab, and you should take a few moments to step back from the code. Just don't do your cutting and pasting and getting it running. Take a step back and actually study the code as well. Before I look at that, I'm just going to go over to VS Code. And I am going to switch. Oh, yeah. This is what I'm looking at here is quite close to what she produced in this week's lab. So this is the stack file. Am I right? Yeah, this is the stack file. There's our table. That's fine. We've talked about that. This is our seeding code, which is fairly complex stuff, that seeding code, but uh, all I all I'm going to say is that behind the scenes, what this seeding code does is it actually creates a Lambda function to carry out the seeding for us, because seeding is essentially writing data to a database. Yeah. And that looks like it's something that needs to be performed by some sort of compute resource. And it turns out that it uses the Lambda compute resource to do that. So this actually does create a Lambda behind the scenes, and it automatically kind of programs that Lambda to perform a kind of a bulk or batch write operation to our movies table. That's what's kind of going on behind the scenes there. But we'll just kind of conveniently skip over it. Here's a lambda. The only thing that's new in this lambda is this part here. Oh gosh, what did it do there? Just collapse that. The only thing new in this lambda from last week's lab is this part here, where we're passing in environment variables into our lambda. And environment variables can be anything you want them to be. In this case, there's no sense now that this is a prescribed environment variable name. It isn't. This is just completely made up. You can call it whatever you want it to be, but that's a sensible name. I think we'd agree. And we're passing in the region as well, because the reason we're passing in the region is because within this Lambda, it's creating an instance of the DynamoDB client, that native client, and that native client has to be configured with the region setting. The fact that I've hard coded it here is not great. Really, what I should have done is, just from a programming point of view, if I go back to this file here, when I create an instance of my stack, just give me 1 second now. When I create an instance of my stack, then you can actually pass in, you can pass in here via here, really. In fact, I did it, but I didn't pick it up actually. You can pass in various, I guess you'd call them environment variables again, really, or they can be anything, any kind of values, really. And those values are then available to your stack file. So if I go back to here, you can get at them from this uh, this parameter. Yeah. Uh, that would have been a better way of programming rather than hard coding it the way I did. Anyway, let's see. So yeah, environment variables, you can have any number of them. They're just key value pairs, really. That was the only thing that was new in that Lambda. And create a URL for it, that's fine. This line here, it's fairly obvious what it's doing. It's giving the Lambda the permissions that it needs to be able to, in this case, write to or perform write operations, or I guess read operations, I beg your pardon, perform read operations against DynamoDB. It's a single line of code, but it's interesting to see what that single line of code generates in terms of provisioning resources. Now, what I mean by that is, so I've CDK deployed this stack already. And if I go to the Lambda part, and if I go into functions, and we notice there are two functions, but our CDK stack only had one function. Anybody want to tell me what's the second function? I can tell you that both of these functions are related to the same stack. You can kind of prove it from the function name. It looks like it's related to the same stack. So even though my stack file only has one function, there seems to be two functions created, two Lambda functions created, or provisioned. What's the second one about? Second one is related to the, was somebody going to speak?
I was going to ask if it was something to do with like a debug version of the function or something.
Nope. No, good guess, but no. It's the seeding. Remember I was talking about the seeding, the custom resource there that we create to do the seeding?
Ah, yes.
Yeah, behind the scenes, it creates a Lambda to do that, and that's the Lambda. Okay, but let's go into the one that we do know about, which is this one, and let's browse around here. There's the actual code. I had problems the last day showing you the actual code of a Lambda, but this is the code, the JavaScript code that was generated by the TypeScript compiler, which is playing a role in the whole deployment process. So that's the actual JavaScript code of my Lambda function. But if I go down to here, what do I want to do? Let's see. Yeah, if I go into here and permissions, and we talked about the execution role the last day. So this execution role is the one that was generated by the CDK for me. And if I go into that, that's an IAM resource that was created for me by the CDK. And if I look at looks like there are two policies attached to that IAM role. This is the policy, one of the managed policies that I mentioned the last day that every Lambda gets automatically. That policy allows it to essentially write logs, streams to CloudWatch. This policy here, though, was created on the fly by the CDK. And if I go into it, and if I look at the JSON, and I'm doing this now because you have seen the structure of these policies albeit a fairly high level in the DevOps module last year. But here's the policy here, right? And it's all about being able to perform operations against the DynamoDB service. Yeah. So this policy was generated as a result of that single line of code. The policy was attached to the role, and the role was attached to the Lambda. Now, that's a very good example of what we mean by infrastructure as code. We write code, but the uh, the various resources that are created behind the scenes, and there are many, is taken care of by the actual CDK framework in conjunction with the CloudFormation service. So that's kind of classic infrastructure as code. Um, and just on that, right, if I go back to here, okay, so the policy, it looks like, if you looked at the detail, it's giving the Lambda a lot of permissions. But really, all my Lambda wants to do is to be able to read an item from a particular table. So in a sense, the Lambda is over permissioned, like it has too many permissions. And sometimes in your CDK code, you actually want to write the IAM policy yourself, maybe because there isn't a nice kind of convenient method that does it for you. So how do we actually do that? And so what I've done is, if we take out this line of code, and if I enable this code here, so here I am actually kind of programmatically, I'm adding a policy to, in this case, to my Lambda. So there's this convenience method that's available to us. And here I am instantiating a new policy. And, it has the usual, it has the kind of attributes that an IAM policy would have. It refers to a particular resource, so it's specifically a policy related to my movies table. And these are the various. Now, what I actually did was I took the policy that I showed you there on the web um, console, and I essentially kind of pasted it in here, right? So these are all the permissions that were given to me as a result of this line of code here, right? But I actually don't need many of them. So I'm going to take out all of them except the get item one. So I'll just comment out all of these. And I'll bring back, let's see this one. Okay. Check to see are there any errors. No. Do a CDK deploy. CDK deploy. So as I said, all I'm demonstrating is how you program using the CDK framework, the creation of a particular policy, a very specific policy, and in this case, attach it to a Lambda resource. Yes. Hopefully it will do it very quickly for me. Now, what I won't do, just because of time, is, obviously I would want to test my Lambda to make sure it still works, but I've done that uh, before the lecture, and it does work. So, but you can play around with this yourselves, and if you want to. And I go back, close off some of these. And as we know, sometimes yikes, did I close off too many? Damn. See, do a manual refresh. Just gamble it, see if it works without doing a manual refresh. Yeah, so that's my new policy now with far fewer permissions. And as I said, it's the Lambda still works. Okay, bit of a sidetrack. Where were we? Okay, back to querying. So, oh yeah, so querying is only something we can do against tables with composite primary keys. Do, 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 do. Okay, querying requests return items based on. Okay, yeah. So I've kind of said that a query in the DynamoDB world, it returns items that are based on a particular partition key value. So it's the equals operator. That's the only operator that's available to you. You can't sort of query on the basis of, let's say, if the partition key is a numeric value, you want all items whose partition key is greater than a particular value. That's just not allowed. It has to be equality. However, the sort key has a number of operators that you can use to express the query that you want to perform. Now, clearly, these ones here only make sense if including this one, they only make sense if the sort key is a numeric type. If it's a string type, the only one that you can really use is this one here, that the string begins with a particular value. So, okay, the numeric ones are fine. There's a number of options available to us, so it's fairly powerful. But for string-based sort keys, that's the only operator that you have for narrowing down the items that you're looking for. And these all apply to just the sort key part. The partition key, you've got to be specific about the partition key value. Why is that? Because you can only query against one partition within the database. Okay, I'm saying here you can include a filter expression in a query request, but the filtering is actually done on the client side. albeit it's done by the DynamoDB SDK. Okay, you don't have to do the filtering yourself in your code, but you just need to remember that the filtering is not done on the server side of this request. It's done on the client side. The query response then, there seems to be certain conditions associated with that as well. There can't be more than 1 megabyte of data in the response in terms of volume. You can, in your query request, you can, even though a query might return from the server side, and even from the server side, it might return, let's say, 100 items. You can specify in the query that you're only interested in a certain number, a limited number, and it'll just return that limited number to you. I think that actually still only happens on the client side, though. The limit doesn't happen on the server side. There is pagination built in as well. So again, like if the query returns 500 items, all with the same partition key, then you can get it to introduce kind of pagination in the response that arrives back to your Lambda function. And again, that pagination is all done by the SDK on the client side of the SDK, if you like. We won't really see that, but just be aware of it. Sample code. Okay, look, I mean, I've made this point a couple of times. If this is our table, okay, it looks like it's customer order stuff, fairly standard kind of stuff. But I think I grabbed this straight out of the documentation, the DynamoDB documentation. This is a customer orders table. The customer ID looks like it's the partition key. The order ID looks like it's the sort key. Well, the only types of queries that we can perform against this table, even though obviously there will be many other attributes, the only queries we can perform are of the nature of give me all of the orders. Sorry, yeah, give me all of the orders for a particular customer ID. And because the order ID, which is a sort key, looks like it's a string, then the only operator that's available to you is where the string begins with a particular value, which probably doesn't make any sense really in the context of an order ID, but hopefully you get the point that it's fairly restrictive. An example, and maybe I'll flick back. Yeah, I'm going to go back to here, the demo world. And I should have done this actually while I was talking. I want to do a CDK destroy. Maybe I'll just talk through the slide while it's doing its thing. Or maybe not. See if I can change branches. Okay, that's good. The stack, I think, has it. Yeah, okay, the stack is gone. Just want to switch branches here to this one. And here's my stack in this case. And while I'm talking, I'm going to do CDK deploy. Okay, here's my stack. Uh, so I've got the movies table, that's the same as before. I've got this movie cast table. So this movie cast table is going to store information about the various cast members for a movie. Yeah. And it has a composite primary key. Partition key is again movie ID. And I've selected as the sort key the actor's name. Uh, Yeah, and there are other attributes as well, but that's my choice for the start key. And then I've got some lambdas, I guess. I've got some seeding. Sorry, we'll skip over this for a second. I've got my seeding stuff, and I'm seeding two tables now, both the movies and the movie cast. And then I've got, that's okay, we've seen that lambda before. And I've got a lambda here. No, we've seen that one before as well. I've got a lambda that's related to querying my cast, my movie cast table. Yeah, let's check. Okay, so that has deployed, I think. Look at the slides, see what my ordering is here. Okay, so we've seen that. And here I'm just showing you from the lambda an example of a query. I guess I could do that in the VS Code, couldn't I? Go into one of the lambdas, this guy here. Let's see now, sorry, I'm slightly disorganized. Let's see what I'm doing here. Okay, let's maybe look at, let's take this one here because the lambda is the lambda in VS Code is a little bit more complex. Okay, here's a query command that I'm passing to my DynamoDB document client, and a query command. You have to specify the table, of course. You have to specify then what's called the key condition. And this is just an expression where you're expressing which particular items you're looking for. And this expression has to specify the partition key of the items that you're looking for. And again, it can only be one value. So the movie ID, which is our table's partition key from up here, movie ID has to be equal to, this is just a placeholder, colon M. Colon M gets its value down here. I know it's a little bit complex, but there you go. The AND operator then, and here is a condition related to the sort key, which in our case is actor's name. And I'm looking for actors' names that begin with a particular substring. And I've just hard-coded this substring here. So I'm looking for all actors in movie 1, 2, 3, 4, where the actor name begins with Bob. So again, it's a query. The query is limited to the partition key, sort key part of my table, and it can't go beyond that. The expression is, you could just say movie ID equals to this and leave out the AND part. In that case, you're getting all of the items in a collection. And when we talk about item collections, in other words, you're getting all of the cast members for a particular movie. And we know that's all going to be stored in one partition and all that stuff. So this is how we program anyway. This is how we program a query request using the SDK, the JavaScript SDK. Now, clearly, there may be other types of queries that you would like to perform. And for that purpose, DynamoDB has this notion of local secondary indices, or LSIs. Technically, an LSI is based on an alternative sort key. So you can have multiple, well, a maximum of 5 local secondary indices. We often talk about the main index, and then we talk about local secondary indices. The main index is determined by what is the partition key and the main sort key. So for our movie cast table, the main index would be based on movie ID and actor's name. A local secondary index for that table might be based on movie ID. It has to have the partition key part, and let's say the the character's name within the movie, if character name is one of the attributes of my table. Okay, so an LSI is another index. It's based on both the partition key, but an alternative sort key. And the sort key can be any one of the other attributes in the table. But you would only define an LSI if you knew that you wanted to make queries based on that alternative sort key. Otherwise, there's no need for the LSI. So it's these LSIs that give us a bit more flexibility in terms of querying against tables that have composite primary keys. Because of the way the LSIs are structured, they're still based on the partition key. LSIs are always going to be stored on the same partition as the main index. There's a maximum of 5 LSIs allowed per table. That's really because, there is a limit to the size of a partition. It's 10 gigabytes. So you can't really have a table that might have 100 LSIs because that's the LSIs are just going to chew up the partition size, and you're not going to be able to store as many items in a partition as you would like. So that's where there's a limit, I guess. These LSIs are used with these query actions, and we'll see how to program that in a while. The attributes chosen for LSIs, sort keys must be scalar. Well, that's okay, because the sort key has to be, well, I didn't actually mention that, but the sort key has to be a scalar type. I guess it would stand to reason. Typically, it's a string or numeric value. And the same is true for an LSI's sort key. LSIs must be defined at table creation time. If I just flip back, I suppose, to my VS Code from a CDK point of view, sorry. Like, here's my movie cast table. This is the basis for the main index. And here I'm adding an LSI, and I'm telling it that I'm just giving a name to that index, but I'm telling it, here's the alternative sort key. It's an attribute called role name, as opposed to actor name. Actor name was the sort key for the main index. Role name is the sort key for this local secondary index. And maybe I should have shown you sample data. It would have helped maybe, but if I go into my seeding, this is my seeding data for my movie cast. So partition key, and then the other attributes. Okay, so one of my main, I know I'm kind of going over it a little bit, maybe too much, but my main index, the sort key is based on that attribute. For my local secondary index, the sort key is based on this attribute. So now it means I can do queries I can query, for example, for all movies with a particular movie ID where the character's name within the movie begins with a particular substring. Here are just some other examples. Supposing I've got a table of discussion threads. I think I took this straight out of the DynamoDB documentation, really. Okay, I've got this table of discussion threads, and it looks like the partition key is its type is string, but it's a forum name, and they're just using the different AWS services as the forums. Okay, the sort key looks like it's a subject for a particular forum discussion. Okay, it should be a string. The strings are meaningless in this case, but you kind of get the point, hopefully. So that's a table, right? And we would refer to this table now as kind of the main index for this table, or also referred to as the primary index. A secondary index then might be where we're using the date, the last posting on a particular forum as being the basis for an alternative index or a local secondary index. So again, in this case, the secondary index, the partition key is the same as before, but the sort key now is a different attribute. And so we can now query this. Now the date is not, DynamoDB doesn't have the concept of a date type. So date in this case is just a string. But because the way the dates are structured, we could run a query against this table, this discussion threads table, where we're looking for, let's say, all items related to a particular service, let's say S3, where the last posting for that service began with a particular year, let's say, or year and month combination. And the DynamoDB server side will be able to execute those queries for us and return the particular subset of records. Can I just go back 2 slides to a point that I haven't made, which is, oh yeah, this point here, right? It turns out, right, that each LSI is a projection of the table. And unless you tell it otherwise, that projection is a copy of all of the attributes for all of the items in that table. So if you don't tell it about the projection part of your LSI definition, which I didn't in my CDK code, in the small bit of CDK code that I showed you there. In other words, back to, sorry, here. I don't have anything here about the projection part of this local secondary index. What that means is that every time an item is added to this cast table, a duplicate copy of that item will be added to the local secondary index. So that's why, again, why you're only limited to 5 LSIs, because the local secondary indexes could potentially be of the exact same size as the kind of main table itself. Whereas if you do have a projection, you can say, look, I only want certain attributes from the main table to be written into the local secondary index. Okay, that's all I need to talk about in relation to LSIs. There is this also the concept of global secondary indices, and they're a completely different beast. Global secondary indices aren't as restrictive as LSIs, as in I said that an LSI is stored in the same partition as the main table, even if that table is spans multiple partitions, each partition within that table will have the LSI entries that relate to the that part of the table in the partition. The LSIs are always referring to items that are local to it from a partition point of view. A global secondary index is different. A global secondary index is stored on separate partitions entirely, and there are different conditions related to its. It can actually have a different partition key and different sort keys. We don't need to look at global secondary indices though. Now, how much time have I got left? I have, okay, a little bit of time. So what I want to do is look at, this is what I'll do. I'll bring up Postman. And I've created a collection here, it is here, related to this cast table. So if I go into this one, okay, so what I want to be able to do, so that let's see, where am I now? Yeah, let's go back to, sorry now about this, let's go back to here. So that's my table stuff, that's okay. And I want to fast forward to this function here. Okay, and that function has a URL generated for us. So I'll be able to trigger it from Postman. And whatever that URL is, I also want to be able to add query string parameters to it. And the query string parameters are these ones here. So I want to be able to pass it a movie ID. I want to be able to pass it a role name. I want to be able to pass it an actor name. Now, the way I've written the Lambda, it's either or of these. I'll always have to pass a movie ID, but I'll either pass it a role name or an actor name. And the idea then is that the Lambda would query the movie cast table and pick out the relevant items that match my query from the query string. Okay, so I've shown you some of the seeding data. So maybe if I just run a query, first of all, I have to get the URL of that Lambda though, which hopefully is available to me here. And I need to paste that into just a parameter that I've declared, or sorry, a collection variable that I've declared. That. Up to here. And let's supposing I want all movies whose movie ID is 1234, and let's say the actor name begins with Joe. Okay, so I'm gonna remove that query parameter. I run that query. And I get back nothing. That's not good. Video 1, 2, 3, 4. What went wrong there, I wonder?
It's a 403 forbidden error.
It's a 403 forbidden error. Where are you getting that from? This is a matter of interest. What did I not look at?
Just to the right of your cursor.
Okay. Let's see. How am I getting that? I did pick up the right URL. There's no authentication required. Did I paste in the right? Let's go back to here. To variables. Pretty sure I pasted in the right one, but just in case. Cast. You get movie cast, which is get movie cast URL, so that's right. That's move 1, 2, 3, 4. That's all okay. Don't see anything changing, but let's see. Nope. Oh, sorry. Okay. Don't know what I did wrong the first time. So it's giving me back two movies. The movie ID is right, and the actor. There's an actor name I asked for. Actor name begins with Joe, so Joe is right there, and Joe is right here. And if I look at the actual data, in terms of my seeding data, for movie 1, 2, 3, 4, I also had an Alice, and it didn't give me that. So it looks as if it's worked all right. So let's have a quick look at the actual lambda. And okay, there's a little bit of processing of the query string because there are a number of options. Okay, first of all, check to make sure that there is a query string. Return error if there isn't. Then I check to make sure that there is a movie ID in the query string. Return an error if there isn't. Then I have to check. I know there's a movie ID now in the query string, so I get it and I parse it because it's going to be come across as a string, so I have to parse it into an int because movie IDs are ints in my table anyway. I then create a structure for my query eventually. Okay, so this structure here now is not finished yet though. I then check to see, well, did the request include the role name, second attribute? If it did, then I flesh out the properties of the command that I'm eventually going to issue to DynamoDB. I do need to tell it what index it should be using if it's not the main index. Now, when I created my local secondary index, the local secondary index was based on role name. And the name I gave that local secondary index, if we went back and looked at the CDK code, that was the name. So I do have to tell it which index it should use when it's performing this query on the server side. If it's the main index, then I do not have to include this parameter at all, or this attribute at all. Yeah. The key condition then is as before, okay, movie ID that, and again, I'm using the begins with operator to express the part of the sort key that I want to have examined on the server side. The actual values that are added to this expression. Otherwise, create this structure for the main index, which was the actor name index, if you like. But it's the main index. I don't have to tell it the index here. So this structure here now is going to be used eventually in my query request. What am I doing here? Oh yeah. Well, if there's no role, if there was no role or actor query string parameter, then I'm assuming that the request is just for all items in a particular collection, all kind of items for a particular movie. That's all I'm doing here. And eventually then I send my, in this case, a query request or a query command, sorry, using this structure that I'm setting up here. Run it and then return the data back to the client. So what's the purpose of this demonstration? And in fact, this is what you will be doing in the lab, the next lab. It's to demonstrate both LSIs, local secondary indices, and query requests using the SDK. Okay, I think that's all I planned to cover today. A little bit ahead of time, but that's okay. I could pause for questions, I suppose, if there were questions. I know you probably need to study this code, but let's try one or two others just to play around with it. Does it actually work? This is kind of showing off time, I guess. Where do I do that? Into parameters. If I disable that, run my query. And I think there were 3 records for movie, 1, 2, 3, 4. 3 items, sorry. Keep making that mistake. 1, 2, 3, yeah. If we switch it to role name rather than actor name. Sorry, this one. So only male characters. It's male and that's male. It seems to have worked as well. And that's the only combination. I just didn't allow, well, you couldn't run a query where you're specifying both the actor name constraint and role name constraint because they're 2 separate sort keys against 2 separate indices. So we just can't handle that. Yeah, that's about it, I suppose. Let me see now. Yeah, I'm going to leave it at that. There is a nice, actually, the very last slide in that set. There's a nice video. It's only about 15 minutes long that talks about DynamoDB, and it talks about many of the issues that I've uh, been talking about over this lecture and this lecture specifically. It's worth a watch, actually, just as kind of confirmation of what we've been talking about. Okay, so you can work your way through the lab and see how you get on, and I will talk to you next week sometime. All right, bye-bye.